Hi guys, today we'll be solving the ninth day's problem of Lead Coding Challenge March 2021. The problem's name is add one row to tree. As we read the problem's name, it seems quite simple, but it is a little tricky because we'll have to create another function which is apart from the one which is already given to us. Let's see what we can do. We can do this problem using DFS, BFS, recursion, or any other method. But today we'll be doing it using depth first search. Let me give you a very quick note. To do DFS, we need stack, and to do BFS, we need a queue. So here we'll be using a stack. Let's read the problem statement. Given the root of a binary tree, the value v and depth d. You need to add a row of nodes with value v at depth d. The root node has depth 1. Okay. The adding rule is given a positive integer depth d for each not null tree nodes n and in depth d minus 1, create two tree nodes with the value b as ends. The left subtree root and the right subtree root. The ends original left subtree should be the left subtree to the new left subtree, and its original right subtree should be the right subtree to the new subtree root. If depth d is 1, that means there is no depth d minus 1 at all. Then create a tree node with value v as the new root of the whole original tree, and the original tree is the new root left subtree. Let's see the example to understand what the question says. Let's read the tree. The tree has values 4, 2, 3, 1, 6, 5. And the v is given as 1 and the depth is given as 2. According to the question, we need to create new nodes on d minus 1. Okay, so and then we'll have to add the values which is given here, which is 1, to the d minus 1 and push the tree further down to the newly created nodes. Let's try to see what I'm saying. So the new tree will be 4, 1, 1. The new nodes will be created here after d minus 1, and then the originally existing tree will be pushed below. Okay, seems quite simple. The second example says 4, 2, 3, 1. The value is 1, the depth is 3. Here the depth on depth 3, we have 3 and 1. So we'll push 3 and 1 below and add 1, 1 to the places of 3 and 1. Here, as this is already 1, we'll overwrite it as 1 and push it down, because we don't care if here the values are already 1 or not. We just need to add the new values and push the existing values down. Let's try to code it. This is what a new class we need to add while coding this, which I was saying earlier. I'm sorry I said function above, but here we have to make a new class node to make our insertion easier. In the node, we'll have a constructor where we'll pass tree node n, as tree node is already given here, and in d node is n, depth is d, and then we just initialize the values of tree node and int depth. Let's try to code it further and understand what the problem says. Firstly, we'll try to do the latter part. Here, if d is 1, means there is no d minus 1 at all. Then create a tree node with value v as the new root node of the original tree, and the original tree is the new root's left subtree. So let's try to code that part first. If d is equals to 1, tree node n is equals to new tree node with value v, and dot left is equal to root. return in. I hope that part is done. We'll see by passing the result. We'll try to run the code, but first let's complete the code overall. As I mentioned earlier, as we're doing a depth first search, we need to use stack. If we were using breadth first search, we'll be using queue, but here we'll use a stack. So let's make a new stack of node data type called stack. We'll push node. Make a while loop. Unless the tree is empty, we try to push it down. Unless the stack is empty, I'm sorry. Node n is equal to stack dot out. N dot node equals to null. Then we continue or else n dot depth is equals to d minus 1. We are doing d minus 1 as it is mentioned in the question here, that we need to create new node, two tree nodes of value v at depth d minus 1. We'll create two new nodes. Tree node, node 10. Let me see node 10. Node 10 is equals to node n dot node left. Here we are taking the left part first. We are taking the value of the left node of d minus 1. The value which is at d minus 1, we are taking the left subtree, the first node which is present there, and we are adding it to temp so that we can swap. Push it further. Now n dot node, n dot left, n dot node dot left is equal to new node with value v. N dot node dot left is equal to temp. So the value which was after d minus 1, we are pushing it to n node minus left of left. So we're pushing it down. Let's do the same with right. Temp 1. So what's next? If this is not the case, then stack dot push new node. N dot node dot left, comma, n dot depth plus 1. For the left node, now we'll do the same for the right node. And now finally we'll try to return root. Let's see what do we get. Okay, so the expected output and our outputs don't match. Let's try to understand why. Guys, so I understood my mistake here. I forgot to write temp1. I wrote temp instead of temp1. So we were shifting the left subtree, we're copying the left subtree of t minus 1 to the right subtree as well. But here, as I have declared a new tree node, so we should have shifted temp1. We should have pushed temp1 to the right subtree. Let's try to run it. I'll show you guys this works. Okay, let's try to submit it. Okay, the solution is accepted. I hope you guys understood. Thank you. I'll see you again tomorrow.